So, hello everyone. Today we are going to solve the fourth problem of Leet code 75, which is can place flowers. Leet code number 605. So, in this question, it is basically says that you have a given a flower bed which contains flower plots, and you have to plot the flowers in it in such a manner that no two adjacent plots are planted, and you have a given integer n. You have to plot that n plots in such a manner that no two adjacent flower bed are planted at a time. Let me explain you more clearly with the example. So you have a given flower bed array like this, and you have given the number of plots. You have to number of plots you have to planted in the flower bed in such a manner that no two adjacent plots are planted at a time. So like this here you have given 10001 plot 1 planted 0. Let me take you to the notepad for more clear. Like this you have a given plot 1, here plot 1 is planted, plot 0 is not planted, here this plot is not planted, this is not planted, this plot is planted, and you have given n is equal to 1. You have to plot a plot 1, you have to plot a single plot in such a manner that no two adjacent plots are planted. If we plant it there, if we plot flowers there, then this and this becomes adjacent, so we not plot here. If we plot it here, no two adjacent plots are planted because it is not planted and it is also not planted. So here we can plot it. If we plot this here, so the adjacent is 1, so here we cannot plant it. Next example, let me see the next example. Here n is equal to 2. So here you have to plot two plots. Plant two plots. So the first is planted. So we cannot plant here. So we cannot plant here. But it is 0. I will show you. So it is 0. So we plant here. So we plant here. Okay. And if we plant here, this plant becomes planted. It becomes 1. So the adjacent are 1. So we cannot plant here. So we only plot only one plot. Still one plant remaining. So it returns false. We cannot plant n is equal to 2. And here n is equal to 1. So we easily plant n is equal to 1. So it is returns true. Let I will show you the solution and explain you. First of all, in this question, we have to think what the extreme cases are. Think if you are given only one plot and it is given one, okay, then what it if n is equal to 1 or 0 n is equal to, what will be the case? If n is equal to 1, we cannot plot it here. So this is false. If n is equal to 0, it is true because no plant is needed to be planted. Okay, think. So here the case is we we would solve the between the cases I is equal to 0, we handle I is equal to 0 and I is equal to 1, I is equal to n minus 1, basically size minus 1, and all other cases we handle it through the for loop. Here you see that. We take out the size of the plot. First of all, we take out the size of the plot. If you are given that no plot is needed to be planted, then it is always true. Okay. But if the size is 1, then there is two cases. Either it is plotted or not plotted. The size of flower bed is 1. Either it is plotted or not plotted. If it is plotted, okay, and n not equal to 0, here we consider that if n is equal to 0, we return it true. So all the other cases which comes till there, here n not equal to 0. So if n is equal to 0, then already we have written true. So here size is equal to 1, flower bed is equal to 0. If it is 0, okay, and n, so return true. Okay. If size equal to 1 and flower bed of 0 not equal to 0, matlab this case, then return false, because here n not equal to 0 and you don't have any extra space so that you can plot here. You don't have extra because it is the size of plot 1, and here size of 0, plot 0 is equal to 0 means you have n, some n given which is not equal to 0, so you can easily plot it. Let me raise it so I will also explain the next conditions. So the next conditions are the extreme conditions. That is this position and the next, that is this position. So in this position we only check for this and this next position. And in position n minus 1 you have to only check for n minus 1 and n minus 2, this one position. All other positions will be handled through this for loop. So here, if the flower bed is equal to 0, if this position is 0 and flower bed 1 not equal to 1 and this not equal to 1, basically this, if also this is 0, then we decrease the number of plots, because here we can plant it. We plant it here, we change it to flower of 0 is equal to 1, okay, and n becomes n minus minus and decreases by 1. Okay. If in the last, if this n equal to 0 or less than 0, it means n equal to 0 or less than 0. It means that there is no plot remaining which need to be planted. So it means our answer is true, otherwise false. We check it this in last. Okay. Till now I has erased it. So this is the first condition. Now we look for this till here, because this is the last case. We check it through if else in the last. So here, if I is equal to 1, here see, I is equal to 1, we, we basically check it from there because we don't want our array to be out of bound. If we check it from here and if we put the condition n minus 1 for n is equal to 0, n minus 1 become out of bound. That's why we have started this here and we check it separately. This and this condition we check it separately. So for this, let me write it clearly here. N is equal to 1. Here size minus 2. So for here, I am saying that if for size is equal to 1, if size of this extra becomes 0, if it is 0 and flower of bed I plus 1 and this also becomes 0, then here we can plant it. So here's the condition: if size of flower bed I minus 1 equal to 0 and I plus 1 is equal to 0, and this also we have to check either it is this position is planted or not. If this position is not planted, then we can plant it. If this position if this position is 0 and this position is 0 and this position 0 not planted, then here we can plant it. Okay, so for the next condition we have to check. So for next we have to check whether this or this position is planted or not. So we iterate for the next and we check I minus 1 here, this position, for this position. If we have planted this position, then we cannot plant it here. If we cannot plant it and it also 0, then we can plant it here. So here we handle it clearly in this. And for the last this position, this n minus 1, here I will show you. No, I think it become messy. I will erase it for understanding with the n minus 1 position. So for this position, which is size minus 2, if size minus 1, basically this last, this size minus 1, if this position, if this, for, we have checking for this position, this, if this position is 0, okay, and size minus 2, this position not equal to 1, so we can plant it here. If this position is 1, we cannot plant it here. So for this condition, we have to check it here. And in the last, if all our n decreases, if n becomes less than equal to 0, so we return true, otherwise false. I will show you in the code. Here you look. If n less than equal to 0, then we return true, otherwise false. I will show you while running this because I have already submitted that, so I will run for you. Look, build runs completely fine. So that's it for the day. Okay, thank you.